So here are the warm-up questions that we did in class and the answers. So make sure you understand all of these. I have worked them out. Your calculator will handle those first three, the 2/3 squared, -8 squared, and then -8 in parentheses squared. The 4x in parentheses squared, the whole base is 4x. Anything to the 0 power is 1. Here, just the x is the base of that 0, so just that equals 1. And 7x to, or 7 times x to the -5. The -5 has a, I'm sorry, the x has a negative exponent. So it goes to the denominator and the exponent becomes positive. If you have any questions on these, please let me know. If you were not in class, here is a brief explanation of how we got to the rule we're talking about today. If I have 2 to the 5th times 2 squared, well, 2 to the 5th means 2 times itself 5 times, so I expanded that, I wrote that out, and 2 squared equals 2 times itself twice. Well, now I have 2 multiplied by itself 7 times, so I could rewrite this with a single base and a single exponent of 2 to the 7th. I see one here that uses variables. So d to the 3rd power is d times itself 3 times d, which is just one of them, right? So now I see that I am multiplying d by itself 4 times, and I got d to the 4th. Well, what we noticed was over here with the 2's, with a base of 2, my original exponents were 5 and 2, and my new exponent was 7. With the d's, my original exponents were 3 and 1. There's a 1 there that we don't have to write. And my new exponent was 4. So that allowed us to make this following rule. The product rule for exponents says that when you are multiplying powers with the same base, they have to have the same base, then you add the exponents. When you are multiplying powers with the same base, you add the exponents. So I see that I have x squared times x to the 3rd power. I can expand this. I can write 2x's and then I can write 3x's. Well, that would give me 5x's total that I am multiplying together. So this is x to the 2 plus 3, which is x to the 5th power. So I have the same base, I'm multiplying, I add the exponents. So next problem, I have w to the 7 times w to the 4. So here I'm multiplying w 7 times. Here I'm multiplying w by itself 4 times. So total, I am multiplying w times itself 7 plus 4 times, which is w to the 11th. So when you are multiplying powers with the same base, you add the exponents. So here are the types of problems we're going to see with this. You see over here, I have 4x squared times 3x to the 5th. So here I have two coefficients. I have two variables that are the same base. So I'm going to write my coefficients together. That would be 4 times 3 because this is really all just multiplication. And then I have x squared times x to the 5th. Now I'm going to simplify. 4 times 3 is 12, and x squared times x to the 5th, I'm multiplying with the same base, so 2 plus 5 is 7. So that would be 12 times x to the 7th. It does not matter how many variables you have. You just put the ones that have the same base together and add your exponents. So in this next problem, I have -4 a cubed b times 3a squared b to the 5th. This is all multiplication. So the commutative property says I can write it any way I want. So I'm going to put my coefficients together, -4 times 3. I'm going to put my a's together, a cubed times a squared, and I'm going to put my b's together, b times b to the 5th. Then clean it up. -4 times 3 is -12. a cubed times a squared. Those have the same base, so I add the exponents. 3 plus 2 is 5. And b times b to the fifth, remember there's a 1 there, so 1 plus 5, that gives me b to the 6. Okay, so the last one, you see 3 different terms that are all multiplied. I want you to simplify it. When you're entering an exponent, when you're having to type one in and there's not a power key, remember to use Shift 6 to show me that you have an exponent. I got negative 30 y to the 6. I multiplied 2 times negative 5 times 3, and then I did y to the first power times y to the second power times y to the third power. I added my exponents, and I got y to the 6. If you were typing this in, you would say negative 30 y, then do that Shift 6, and then the 6. That would show me that you meant an exponent there. Now let's combine the product rule with our zero rule and our negative exponent rule, okay? So I have x to the 0 times x to the fifth. Well, these are multiplying with the same base, so I'm going to add the exponents, and 0 plus 5 is 5. So I get x to the fifth. And if you think about it, this makes sense. X to the 0 equals what? X to the 0 is 1, and 1 times x to the fifth would be x to the fifth. The next problem, I have w to the ninth times w to the negative 7. Well, these have the same base. I'm multiplying, so I add the exponents. And 9 plus negative 7 is a positive 2. So this would be w squared. Look at the next one. I'm multiplying with the same base. Tell me, when I add the exponents, what would my exponents be? My exponent would be negative 2, right? 7 plus negative 9 is negative 2. Well, remember I told you that the rule that they told us forever ago was that we can't leave negative exponents in our answer. So we need to simplify or fix w to the negative 2. And remember, w to the negative 2 is the same thing as 1 over w squared. All right, let's look at a couple that look a little scarier. Here I have 6 times x to the negative 8 times negative 3 times x to the negative 3. So I'm going to write my coefficients together. 6 times negative 3 times, we're using the commutative property here, I'm going to write x to the negative 8 and x to the negative 3 together. Well, 6 times negative 3 is negative 18. X to the negative 8 times x to the negative 3. I keep the base. I add the exponents. I get x to the negative 11. Well, we have to fix that x to the negative 11. The negative 18 is fine, so it's going to stay in the numerator, and x to the negative 11 is going to jump to the denominator and become x to the positive 11. So sometimes we're going to get some funky looking fractions. All right, one more. So I have 4 c to the 8th d to the negative 3 times 5 c to the negative 5 d to the negative 1. I want you to look at this. Tell me what my new coefficient is going to be. My new coefficient is 4 times 5, which is 20. Now look at the c's and tell me what the new exponent of c is going to be. I have c to the 8th times c to the negative 5. So 8 plus negative 5 is 3. So my new exponent for c is 3, c to the third power. Now look at the d's and tell me the new exponent for d. It's d to the negative 4, right? I have d to the negative 3 times d to the negative 1. Those are the same base, so I add the exponents. Negative 3 plus negative 1 is negative 4. Well, now my d has a negative exponent, so it's got to be simplified. It's got to be fixed, right? So the 20 is good. We will never swap a coefficient because it's not an exponent. The c to the third power is happy. It's a positive exponent. The d to the negative 4 is going to hop the fraction bar, so it's going to go into the denominator, and it's going to become d to the positive 4. So there's what we do with the product rule, and now you're ready to practice.